Bismillahirrahmanirrahim. Dear viewers, now I am going to show how to apply the loads in 3D portal frame. In previous tutorial, I have shown how to calculate the loads, and we all know that wind load calculation is the most critical and sensitive issue in 3D portal frame design. So we have to understand the load calculation, wind load calculation, and we have to understand the loads affecting the frames according to the wind load direction, how it is affecting the frames, and the load direction, resultant load direction will be the of uh, factor during the load application. So let's start. I will try my best to explain the wind load effect on these frames. Now let's first come to that point. Wind load perpendicular to ridge. That means this is our ridge line. Middle of the uh, building width is our ridge line, and this is the top. This is our ridge line. Perpendicular means this side or reverse side, and parallel to ridge means from wind direction from this side, parallel to ridge line. So we will first apply the wind load perpendicular to ridge line. First we will go to here, you see this y direction. So in y direction we will apply our first wind load. Before that we can apply our other loads, live load, dead load, and collateral load. So let's go for that one. And this load will be applied only to the roofs, that means on the rafter. So click on here. First let's define our load patterns. There by default there is dead only. Then we will add collateral. Add this collateral load. It will have self weight multiplier, because if there is anything hanging load, that will be act as a dead load permanently. Live load, add, and this live load self weight multiplier 0, because this will not be considered during the earthquake or seismic effect. So that's why 0 self weight multiplier, and this is 1, this 2 is 1, because this must be considered during the seismic occurrence. Now wx wind, and here it will be user defined, because we will apply the load according to our calculation. Add, then w, here it will be wx plus modify wx plus modify load pattern. Okay, now wx minus add wy plus add, and wy minus then add. Okay, now we will apply our loads. Go to dead load first, then here by mistake I have pressed one button, that's why that was coming. Okay, now go to this first dead load 0.44, I will apply 0.45 0.45 on gravitational direction. Okay, and for the in frame this will take half, because half of the total load, because this frame having two sides. This side also there are roof wind load is affecting on the roof, so that roof area half portion of this side, half portion of this side, that means here coming 5.5 meter width, but for the end frame only half portion of this side no roof, so it will get the half of the total load. Okay, now we will apply our collateral load 1.38, that means I'll apply 1.4. okay, sorry, this is dead load, we have to be careful. Click on this, then CL, then 1.4, apply. Okay, now come to the end frame rafter. Okay, this divided by 2. Okay, now we will apply our live load 3.13, that means we will apply 3.14. I am taking a little bit more, 3.14 after decimal places. Again this and make change, apply. Okay, then this side, this divided by 2. Okay, now we will apply wind loads. Wind perpendicular to ridge, I have explained before in the beginning. This is our ridge line, and perpendicular to ridge, that means from this direction along to y direction. Okay, now Windward Wall 3.85 kilonewton per meter. This is our along y direction, here this y axis, so this is our Windward Wall. So first start Wi plus, what is the load value? 3.85 kilonewton per meter. Sorry, this load direction we have to change, here global y direction. Okay, apply. Now in the end frame, this is our Windward Wall, so this will be half this. Okay, now Windward Wall finished. Windward roof, this negative sign means this is pressure upward, this load will be outward side, 4.4. this one we will select is local 2 and minus, no need to minus, let's check 0. This is 4.4, apply. Okay, then this side it will be half. Okay, now leeward root 2.75, this also outward side 2.75. okay, and end it will be half of this. Okay, Leeward Wall also it is coming 2.75, then we will go there 2.75, and this will be global and y. Okay, local means this local means the frame axis, along two axes it is acting, so it is going upward in the along inclined z axis. Okay, now 2.75, this frame it will work as global y divided by 2, this. Now for side wall 4.62. okay, side wall, for side wall this one 4.62. this will act along this along against the x-axis. When wind uh, wind direction in this direction, then the frame and the roof and wall wants to go outside. That means wants to move outside. It wants to move outward, roof wants to move outward, and this roof also wants to move outward. That's why the load direction like this. So apply here. This one how much? 4.62 minus 4.62. Here will be the direction x. Okay, apply. If I want to see here in 3D, we can see standard. Now see this. Oh, this is the load direction. When load is going along y direction, then this is the effect. And for these two, this wall, if it is enclosed, now we have considered this is enclosed. That's why this wall area load distributing half of this side to this frame, half of this side to this frame, and here half of this side to this frame, half of this area to this frame. In this way, these two frame having full distributory width, and these two frame will have half of the width, distributory width. So this will be like this, and here we will not replace existing load, we will add to existing load, then apply. So it will be like this. In this frame there will be two load, and in resultant the load will apply to the not really to against x-axis. This resultant will act in inclined of negative x-axis. That means it can be 45 degree, and the value will be different because 1.93 and 2.31. Okay, this is our load application when wind is blowing to y direction. Now we can similarly apply wy minus in the other direction. So after finishing wy minus, say we will check by this way. This is wy plus, the load is like that, and y minus same load, just reverse, same loading value, just reverse, wy plus and wy minus. Okay, after finishing this one, we will go to wx plus. That means along to the ridge, parallel to the ridge along x-axis. So let's start. Wind parallel to ridge. So this both roof, that means this roof and this roof. When wind was perpendicular to ridge line, then it was the windward roof and it was the leeward roof. But when wind will blow parallel to ridge line, then these two roof will be same. Okay, so both roof 4.4 meter. I'll select both and then apply load. Here load pattern we will change, we will make it wx plus, and load direction will be local to axis, then 4.4. Okay, and for the end frame it will be half, like this. Okay, now for last both rafter, this one will be at last rafter, this one I will do it later. Now windward wall, that means 4.9. this is the windward wall, global x-axis, this is 4.9. Okay, if we want to see here in 3D, we have to change it is WA plus WA minus date line and WX plus. This is the WX plus. Now for this frame it will be half like this. Okay, now for leeward wall, that means opposite of this wall, when this one will be at last, I will show this one. Now finish this side wall. 3.63 outward pressure, that means when wind is going in this direction, then this 2 is side wall. This one will be negative y, then the value will be 3.63 minus 3.63. apply like this, and this one will be along positive y direction like this. Okay, and for this one it will be like this, and for this one negative sign this load coming from half of the area, wall area. Okay, so don't need to be confused why two load is coming here. For this side, this half area load along this direction, and for this side wall, this half area load coming at this frame. So two load in this frame, because this side is having wall and here no wall. In the interior frame there will be no wall affected by the wind. Wind will affect to surrounding the surrounding the whole structure on the side wall and roof sheets. Okay, now we will I will copy this one. We have to apply leeward load. Okay, copy with support also. Go to replicate, pick 2 point from here to here, apply. Okay, now for WX plus I will apply load. This last both rafter will be 2.2, that means half of this 2.2. the load will be less when wind coming from that side. Leeward side will be load effect less than the windward side. So this one will be 1.1 local to 1.1, apply. This is adding, so I will not add this one. I will make it replace. Okay, like this. Now as it is wind direction, here this load will be changed. First this load will be changed, like leeward wall 2.8, replace global along y direction 2. Leeward wall 2.8, apply, and this will be almost 2.8 divided by 2. this one the value 1.4. okay, if I replace, then this 1.282 also will be replaced, no problem, I will add later. Okay, now I will add here y direction 1.82 and this side minus 1.82. sorry, it is replacing. I will add. You have to be careful when you are doing this one. Apply this one, apply. So this two load coming like this, and we will check for other load because wy plus wx minus we will apply wy plus this is outward, so we have to make this one outward. Go to wy plus and 4.62. I will add this one, then it will be deleted. 4.62, not like this. This one will be along x-axis. Apply, then again do it. Now it is outward, and this 2.31 I will make it outward. So 2.31 like this, again this. Okay, now wy plus finished. For wy minus we'll check it. Wy minus for this one also we have to change. This one also 4.62. apply. Sorry, this one not like this. We have to change wy minus, then select this one, apply like this. Again select this one, apply. Now this 2.31, that means half of this. Apply, again apply, then it will be outward. Okay, now our load application finished for these three frames. Only now balance is wx minus. We will do it in similar way as I have done in wx plus, just directionally. This value will be this side and these values will be this side. Now we have finished wx minus load also. You can see the load effect. This is wx minus when wx plus was like this. Wind was blowing along this direction, then load was affecting like this. And when it is wx minus, then the load is affecting to the frame like this. So we have finished our load application. Now we will copy this interior frame to other grids. So copy this one, select this one, then go to replicate, and as the grid are in same interval, then we will pick 2 points from here to here, that is 5.5, and number will be 1, 2, 3, 4 and 5. Number will be 5. So apply. Okay, now here you can see all the load. We'll start from dead load, collateral load, live load, then wx plus, wx minus, then wy plus, W Y minus. So this is our all loads. This wind load application in SAP and Start Pro are like same. We have to calculate it and we have to apply in the frames. But in global RFEM there is uh, a option to calculate the wind loads automatically, so it will save a lot of time. And in robot structural analysis there is a load simulation engine in that software, so that is also good for wind load calculation. But as it is SAP and Start Pro is commonly used software, that's why I am showing this tutorial, and this will help all of us who is using SAP and Start Pro. In next time after finishing this one, I will start the course on Start Pro also, so stay tuned. And if you want to see in the if you want to see or check global software, global or FEM, you can go to my channel and you can check this video, this modeling of 3D portal frame and applying load in global RFEM. This is the tutorial name, and you can see here, you can see here the
And there is
load
5
application.
will provide.
First here it will be modeling, then the
Right.
load application. Here it is very easy. Wind load application
Okay.
is very easy.
Loading.
So in the next tutorial for this SAP design course, I will add stud or tie beam at the middle, at the ridge and the edge of the frames, corner of the frames, to connect all the frames to each other. And I will add bracing also. After adding this, I will go for analysis and design. Till then, stay tuned.
Press the bell icon on the YouTube app and never miss another update.